1366p. What is it? Why is it? This video will explain everything you didn't need to know about 1366p. You may have noticed that in most laptops, the screens are not 720p or 1080p, but instead some really odd resolution of 1366 by 768. Going back 15 years, laptop screens were a nice clean 1280 by 800, and compared to 1366 by 768 screens, they only have 2.5% less pixels. So why have laptop manufacturers chosen to use this odd and bizarre screen resolution over 1280 by 800? The main reason is to do with aspect ratio, which is the ratio of horizontal to vertical pixels. Aspect ratio will define how wide or tall your image is. Most phones use an aspect ratio of 9:16, while a perfect square is a 1:1 aspect ratio. 5:4 was used in older computer monitors, while 4:3 is used most in CRTs. 3:2 is commonly used in photography. 16:10 used to be widescreen on computer monitors, and 16:9 is the most common aspect ratio on displays and televisions, as most media is filmed at the 16:9 aspect ratio. Most YouTube videos will play back with a 16:9 aspect ratio. 1280 by 800 is a 16:10 aspect ratio, meaning that watching a 16:9 YouTube video will have black bars on the top and bottom, which can take away from the viewing experience. You may be wondering that if we just wanted 16:9 displays on our laptops, why couldn't we have gone with 720p? It's a nice clean resolution at 1280 by 720 and has been used in many HD televisions. The main reason why most laptop screens aren't made at 720p is to ensure compatibility with older programs. There are a few programs from the early 2000s that would only run at specific resolutions. Some programs would only run at 1024 by 768 and nothing else. 1024 by 768 fits perfectly into the 1366 by 768 screen resolution. If laptop screens were to have a screen resolution of 1280 by 720, they wouldn't be able to display the 768 rows of pixels required during the program, and therefore cannot run it natively. The result was that we multiplied 768 by approximately 1.778 to achieve a 16:9 aspect ratio. This ended up with the amount of horizontal pixels being 1365.333. We rounded to an even number to reduce complexity, which results in the final resolution of 1366 by 768. This is also the reason why the resolution can be referred to as WXGA, meaning widescreen XGA. Additionally, you may have seen that your computer gives you the option between 1366 by 768 and 1360 by 768. It's only a 6-column difference and seems odd as it's not even a 0.5% difference. So what gives? It has to do with storing the data for red, green, and blue channels. Each pixel on your monitor is made up of subpixels. These subpixels emit either red, green, or blue. Each subpixel gets assigned a brightness value, and combining all 3 subpixels can create almost every color you can think of. Most monitors have 24-bit color displays, which means that each subpixel has 8 bits to specify its brightness value from 0 to 255. Displaying a 1366 by 768 24-bit image will take up 1024.5 kilobytes per color channel. Now you could only manufacture memory capacities in powers of 2. So in order to store 1024.5 kilobytes, you will need a 2048 kilobyte memory module for each color channel, which costs more than using 1024 kilobyte memory modules. Using a resolution of 1360 by 768 means that each color channel uses 1020 kilobytes each, meaning that we can use the more cost-effective 1024 kilobyte modules, which makes the total cost of the monitor less with an unnoticeable difference in resolution. And that is everything you didn't need to know about 1366p. Thank you for watching. I hope you learned something you didn't need to know.